Hey all, my name is Aditya Maladi and I am the head of mobile engineering here at Keyri. And in this video, I'm going to show you how to set up server-side authentication with Firebase and Keyri on an iOS application. We're going to implement QR authentication as well as local authentication, both passwordless and with password. Okay, so in this, I'm going to show you first how to register a new user using passwordless auth with Keyri and Firebase. So as you'll notice, we have a Swift UI view here, and we basically just have two buttons, one for register and one for login. Right now we're going to focus on register. Now, the first thing you'll notice is we have this little boilerplate code that actually triggers Face ID, and in the Face ID call, if the authentication using biometrics actually passes, that's when we actually go through the Keyri and Firebase component of registering the user. Now, I'm going to jump into this register user function. And what you'll notice first is that we're not actually talking to Firebase through the SDK at all in this component. What we're doing is we're basically generating a key for the user. If it it's definitely not going to exist because we're registering. So we're generating a key for the user using Keyri. We're sending that key to a server that we have implemented here. And that key, that server is going to actually register the user and generate a custom token for us. So only after registration actually happens do we actually go ahead and talk to Firebase. So in the registration component, Firebase is not involved at all. So what we're doing basically is declaring a key, and we are generating the association key here. This if check is actually unnecessary because we're generating. So I'm going to just delete that. And essentially, that's all we actually need, is just generate the association key. Obviously, in a real life scenario, don't use force unwrapping. I'm doing that here just to keep the code as simple as possible. But after that key is generated, what we're going to do is generate the body of the HTTP request as follows. Essentially, it's going to be a JSON with the email, and we'll actually use the email that we're getting from the user, and the public key that we generate from Keyri. Then we're going to go ahead and just create a standard URL request. This is the URL that we're using. Again, don't use force unwrapping. In this case, it's safe because I know it's a URL. It's hard-coded. We're going to post it, and then we have a few pretty standard headers that we're going to use. Obviously, wherever you implement the server, you may have custom headers and things that you need. And then in the URL response, what we care about is the data that we get back from the server. And in this case, we're going to get back a token, a custom token. And that token, which we're just unwrapping as a string using UTF-8, we're going to use to plug into auth, Firebase auth. And we're going to use this with custom token method. And once you successfully have that call go through, you have the user and you have authenticated on the phone. Next, I'm going to go through the login flow because it's actually very similar to the registration flow. The only difference actually is what we pass in to the server as the body of the HTTP request. What we're going to do is, again, use the Face ID wrapping just to guard against, ensure that it's actually the user. And we're going to call the same, we're going to use the same class, but we're going to call the login function, and we're going to use the username again. And we're back here. So in this, you'll notice it's actually very, very similar in terms of the overall structure, where we're generating, all of this code is generating the payload for the HTTP request. We're making the request. We go ahead and get the token. Here in this case, I haven't actually named the variable. I'm just taking it directly, but it's the same thing. I can just do that right now. And this will look exactly like it does above. We're So basically, again, the only difference here is that instead of sending email and the key, now that the server has the key, we're going to actually use the key that we've stored in the keychain and the secure enclave to actually sign a piece of data. And the server is actually going to then go ahead and use the key, the public key that it has saved, to verify the signature and ensure that it's actually coming from the device. That's the power of using all of this cryptography, is that we can ensure that the device is the correct device and it's not just a fraudulent request. So we're going to go ahead and instantiate Keyri. We're going to get the association key this time, and this code can actually go away. I copied and pasted it from above, but we do not need that anymore. We're just going to go ahead and get the association key. And then what we do from there is we generate the timestamp, which is just the date since 1970. And we're actually going to go ahead and split it with a period. This is just a little bit of formatting that we have to do to get the timestamp to work between JavaScript and Swift. So what's going to happen is it's going to generate a timestamp, something like this. Some numbers and then a dot and then 4 more. And the way we need to give it to the service is actually just like this without the dot. And so this code just splits it and then takes the two pieces, adds them together, and creates that string. And we're calling that timestamp underscore nonce, where, oh, I'm sorry, the timestamp is what I just described, and then we're just going to create a random integer between 0 and this big number, and we're going to just add that with an underscore, and so the end result is the timestamp underscore this random integer or nonce, and that is going to be ts underscore nonce. That's the data. You'll notice in this field here, email is self-explanatory, it's just the username, and then the signature. So all we really need to do is generate the signature using Keyri. The nice thing about Keyri is that it saves you from the trouble of having to go through and actually get the key and then sign it yourself. We have a built-in function to actually just sign the key that is associated with the username that's being passed in, and the data is just the string that we've generated, and we'll encode it using UTF-8. So email, self-explanatory, username, the data is the timestamp underscore nonce, and that can just come in as a string in this case. And then the signature is the signature that we're using, the public key from this username signing this piece of data here, and that signature is going to go in as a dir representation, and we'll just use base 64 to convert it back to a string. And then after that, everything else is the same. We generate the URL, we have a different endpoint, that's the only difference. Everything else is the same. The headers are the same, it's a post request, and then we come back, we use the shared data task as usual, and we unwrap the data. If we get the data back from the server, we unwrap the token. Obviously, don't force unwrap in real life. And then we're going to use auth custom token, pass the token in, and we have a user. That's it. It's essentially just sending off that little piece of information, the payload. For registration, it's the key and the username. For login, it's the email, the username, the data, which is the timestamp underscore a random integer or nonce, and then the signature of that timestamp underscore nonce with the key that you've already saved. At that point, you send it to the server, it gives you a custom token, and then you can use Firebase's SDK to authenticate the user with that custom token. It's pretty straightforward. And in this final piece, I'm just going to quickly demonstrate how to implement QR auth using the same Firebase server-side approach. So what's going to happen here, and actually I don't need this anymore because this is from the previous function, but that's actually the key point, is this is actually very similar to the login via server-side Firebase approach, where we are putting together, this will look very familiar, we're putting together the same exact format of a payload where we're sending the email, the data, which is that timestamp underscore nonce, it's the same exact code that we're using to generate that, and then the signature using the key that's stored for the username that's passed in of the timestamp underscore nonce. So this code is exactly the same as what we're using above, The only difference is now, rather than sending off a request to that service that we've built, we're going to import Keyri, or we've already imported it. We're using it for the key generation. But what we're going to be doing is sending through the easy Keyri auth function the payload, which is just that same login body, this exact same payload formatted the same way. We're going to be sending this through Keyri to the browser that the user is trying to actually log into. And what's going to happen with this function is we handle everything from launching the scanner to actually scanning the QR code, creating the session, encrypting this payload securely by doing a key exchange with the browser, and then sending it off to the browser and having it decrypt. We even showed the user a confirmation screen just to ensure that they feel 100% secure in that situation. And if there is a risk analytics flag, for example, if the user is using a VPN or if the distance between the browser and the mobile device is very far, based on the way you configure Keyri to handle that, we may block, warn, or just let that pass through. So the three options are block, which is the login attempt fails, warn, where we just show the user a message saying, hey, there's something potentially weird going on, or we just let it pass through. So this one function handles all of that for you. It's very simple. You just have to call that one function. You get the app key from the Keyri developer portal. As we said, you can pass in the public user ID if you would like. And then the payload, again, is just that login body that we've generated here. And we've already gone through that before. And we're going to go ahead and put this all together now. As you can see, I'm trying to log in with user123@gmail.com. I've already registered this user with Keyri's service. And now we have the web app with the Keyri widget right here. So what I'm going to do is press the login button. As you can see, I was authenticated using Face ID, and now this confirmation screen has popped up. It all looks okay. I'm in Boston, and this is the exact browser that I'm using. So I'm going to go ahead and accept the prompt, and we're in. As you can see, user123 is the logged in user on the web page, and we got through this whole thing without using passwords. It was just biometrics, and it was only, a few dozen lines of code. Pretty straightforward. It's pretty powerful. If you have any questions, please feel free to reach out to us. We also have our code on our GitHub, including this test app. You can play around with it. You can try to set it up in your own environment. And of course, we're here to help you out. So thanks for watching.